In this video, we are going to begin our study of probability. So, what's probability? It's the mathematical theory of uncertainty and randomness, things that could turn out in multiple ways, and you don't know which way they're going to turn out yet. So, if you're visualizing flipping a coin or rolling a die, then those are probability events. So, why are we doing probability? The thing is that probability is actually deeply fundamental. It's at the very heart of many, many things that we do in computer science and applications of mathematics. So, for example, probability is fundamental to the theory of algorithms. So, if you want to know how your algorithm is going to do, how long it's going to run, for example. Well, guess what? There's lots of possible different types of inputs to your algorithm. You don't want to necessarily analyze how long it's going to run for each individual input, but instead you can ask questions like, hey, how long is my algorithm going to run on average? How long is it going to take on average? The idea of average is an idea from probability. We're saying, hey, I'm going to look over all the possibilities, think about how likely they are, and then combine that information. And then similarly, you can ask questions about, hey, if I run an algorithm for some amount of time, how likely is it that I'm close to the best solution to a problem? For example, finding a path through a graph or on a map or something like that. Probability is also at the heart of data science and machine learning. So many learning algorithms for extracting information from data or making predictions, work by constructing what we call probabilistic models of the data. So these are models where you explicitly reflect, hey, the data could be this way or it could be a little bit different. And then you learn the structures of those models from the data, and then that structure allows you to make new predictions. On a related note, essentially the same idea, but reflected a little bit differently, generative models, so a lot of the things that often now get marketed as artificial intelligence are generative models. So text and image generators, these kinds of models work by forming complex probability models describing what kinds of outputs are most likely. So a good text model will say that, hey, valid English sentences are much more likely than nonsense sequences of characters, and it learns that from data. Then, finally, probability is deeply at the heart of essentially every kind of experimental science, especially through the lens of statistics. So, when we do experimental science, we need to go out into the world or into a laboratory and do some experiment that tests a hypothesis. But when you look at the data that you collect, the data doesn't just say, hey, your hypothesis is true, your hypothesis is false. That's not how data works. Instead, the data just tells you some things about the world. And what you need to do is interpret that data through the lens of a statistical model that tells you to what extent the data offers support for your hypothesis. And so probability is really at the heart of everything scientifically we do to learn about the world. So there's lots of reasons to study probability, and we are going to pursue that topic now. Okay, let's get into it. Sample spaces, outcomes, and events are three concepts at the very, very heart of probability. They're what the whole theory is based on. So let's check it out. Here's the deal. We're going to do some kind of experiment in which we do something random. So you could imagine flipping a coin or rolling a die. These are two examples, kind of prototypical examples of random events. We can also think of drawing a card from a deck of cards. We'll have lots of examples we can play with. So when we do something random, something is going to happen, and we call what happens an outcome. So here's an example. I'm going to flip two fair coins. Each coin can come up either heads or tails. And so in this experiment where I flip two coins, I have four possible outcomes. So I could get two heads. I could get one heads on the first coin and then a tails on the second coin. I could get tails on the first coin and then heads on the second coin, or I could get tails on both coins. And I'm going to collect all these possible outcomes, all the things that could happen. I'm going to collect everything that could happen, and I'm going to give a name to that set. So the set of all possible outcomes is called the sample space. So we have a random experiment in which we do something random, and then something can happen. There are many possibilities, and the set of all of those possibilities we call the sample space. So in our example here, this set that I've called S of size 4, that was the sample space. We can also do more examples. So here's one. Suppose that I roll a six-sided die. So a six-sided die has faces 1 through 6. And so then if I look at what face comes up, I can have 1, 2, 3, 4, 5, or 6. The set of all of those numbers would be my sample space. Okay, so each individual thing in my sample space is called an outcome. It's often very helpful for me to group outcomes together. So maybe I'm rolling a die and I don't really care that I get a 1, 2, or 3, but I just care that my result is less than 4. So all of these possibilities are good enough for me. Or maybe I'm flipping my coin and I want to know that I get at least one tails. And so these 3 possibilities are all good enough for me. When we think about these possibilities, you notice I described these with English words, so less than 3 or at least one tails. So what we are going to consider is something called an event. So an event is just a subset of the sample space. So for example, my less than 4 event is just the subset 1, 2, 3. My at least one tails event up here is the subset HT, TH, and TT. So an event is just a subset of the sample space, and we often can describe these events with English words. So here's just a written example that we've seen already. So suppose that I flip these 2 coins, so we get a sample space that we've seen before, it's this one. And I'm going to define E to be the event that we get at least one heads. At least one heads. Then E, formally, technically, is the set of all the outcomes that include at least one heads. And so E is this set of 3 outcomes here. It's a subset of my sample space. So once I have the idea of sample spaces and events, I'm actually all set to start calculating in some simple probability problems. And that's what we'll do next.